Yo, 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 yo. Hey guys, so we're in 10.1 dilations. So with dilations, a lot of key terms, okay? Dilation, center dilation, enlargement, reduction, and scale factor, okay? One of the big terms we're gonna focus on today is dilation, and then also scale factor, okay? We do need to know what's an enlargement and what a reduction is. An enlargement is when we increase the size of something, a reduction is when we decrease the size. And the way we decrease or increase the size of something is by using a scale factor. Now, what you want to do, next to your scale factor definition, you might as well put this, because I think this will help you out. Put new over old. This is the ratio for a scale factor. Or you could even put like image over pre-image. Either one of those will help. Okay. So now, and I'll show you how to use that in a little bit. So when we dilate, we make things larger or smaller. We maintain the same shape. However, we are changing the size of that shape. So this triangle, when I dilate it by this factor of 1/4, what I'm going to do is it's going to make this smaller because this is a number less than 1. So whenever the scale factor or the factor is less than 1, it's going to make it smaller. Whenever it's larger than 1, it's going to make it larger. Now, this factor is how I'm going to know, this is how I know how much larger or smaller I'm going to make the image. It's by this factor, which is also known as the scale factor. So what we do is we take the points from the pre-image, our original image. So let's look at this point right here. This is 1, 2, 3, 4. So that's at -4, 0. This one's at -4, 1, 2, 3, 4. And then we're at 0, 4. Now, so those are my 3 points. I just wrote them down under pre-image. What we do with the scale factor when we're doing a dilation is we multiply every single value in that point by the scale factor. So for this point right here, I'm going to do 1/4 times -4. I can also have to do 1/4 times 0. And that's going to give me my ordered pair. So I'm taking the x and the y and I'm multiplying it by whatever the scale factor is. So 1/4 times -4, well, that's 4 over 1. That just gives me a -4 over 4, which is -1. So that's -1. When I multiply by 0, it's 0. So this now becomes the point -1, 0. So what I did is I took this point, I multiplied by the scale factor. Now a nice little trick is whenever you multiply by 1 over anything, let's say it's 1/5, or if I multiply by 1/3 or 1/7, multiplying by 1/5 is the same thing as dividing by 1/5. Multiplying by 1/4 is the same thing as dividing by 4. And I'm sorry, I think I said that wrong. Multiplying by 1/5 is the same thing as dividing by 5. Multiplying by 1/7 is the same thing as just dividing by 7. Multiplying by 1/3 is the same thing as dividing by 3. Multiplying by 1/4 is the same thing as dividing by 4. Let's look at that. If I took -4 and I divided it by 4, I'd get -1. So that's 2 ways to look at it. But really, we always just multiply our scale factor by the point. So knowing that I'm multiplying by 1/4, which really means I'm dividing by 4, so I'm taking all these points, I'm just dividing by 4. Well, -4 divided by 4 is -1. 4 divided by 4 is 1. There's my next point. 0 divided by 4 is 0. 4 divided by 4 is 1. 0. So now the triangle became this. So it's the same exact type of triangle, but it became 1/4 of the size smaller. We divided everything by 4 to make it 1/4 the size of the original triangle. And I'm done. That's it. So here's the new points. So I took every point, I multiplied it by 1/4. Every single corner I had to multiply the x and the y. The x and the y, the x and the y by 1/4. And that's it. Let's look at another one. So now I got a scale factor of 3. So because it's a scale factor of 3, what I'm really doing is I'm making everything larger. So if I have A, B, and C, the point A here is at 1, 1. B is at 3, 1. And C is at 1, 3. So what I'm doing is I'm taking all of these points and I'm multiplying it by 3. So my new A is going to be 1 times 3. And my y value is going to be 1 times 3. Well, 1 times 3 is 3. So this A now moves over to 3, 3. Here's my new A. For my new B, multiply by 3, multiply by 3. That's going to give me 9, 3. So my new B is going to be at 9, 3. So here's the new B. So that's going to make this side 3 times larger. Because look at this side. 1, 2. Now it's 1, 2, 3, 4, 5, 6. So I went from a length of 2 to now a length of 6 because I multiplied it by 3. Finally, for C, I'm going to multiply by 3. So that's going to give me 3, 9. So that's 3, 9. There's C. Whoop. And then there's the new triangle with the scale factor 3. I made it 3 times larger. Algebraically, make sure we get this somewhere where we can easily see. The algebraic representation for dilations is we take our x and our y and we multiply them by whatever the scale factor is. So we use the letter that we use to represent scale factor is K. I don't know why. But so I take the K and I multiply it by X. I take the Y. I take the K, which is a scale factor, and I multiply it by Y. This is the algebraic representation. So for this particular problem, the way I would actually write it is I take my original XY and I multiply everything by 3. So that's 3 times X, and that's 3 times Y. This shows me what I'm doing to my point. So this K means scale factor. But the scale factor for this problem is 3, so the algebraic representation of this problem will be I'm taking my x and my y and I'm just multiplying them both by 3, so I'm just writing it as 3x and 3 times y. Now, sometimes what you'll have to do is you'll have to actually find the scale factor based on what you see. So we got to figure out are we making it smaller or larger. And then this is where, when I told you guys earlier to write new over old, it makes it really easy to find a scale factor. So here's what we do. We look at what's the original image, I call that old. What's the new image? That's this one right here, or pre-image and image. So we know that by these apostrophes. What I'm going to do is I'm going to take any point from one of these images. Let's take this G right here. So at G, looks like my x is 2, my y is 3. Well, at this G, my x is 4, my y is 6. So I'm trying to figure out how did I get from here to here? How did I get from 4, 6 to 2, 3? Because that's where we started, that's where we ended up. The way we do that, to find our scale factor, we set up just pick an x from each one. So because I'm looking at G, if I take the x from the G and I take the x from the new G, I'm going to take 4 and 2. And those are the values I'm going to use. But I set it up as the newer point on top of the older point. So the new one, this is where we ended up, is 2. The old one is 4. So my scale factor is 2 over 4, which can be simplified to 1/2. Because what I did is I took this point, I just divided everything by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So that means this has a scale factor of 1/2, and I'm done. If I didn't set it up as new over old and I set it up as like 4 over 2, then we're going to get a scale factor of 2, saying that we're making it larger. But because we're making it smaller, it has to be a fraction. Okay, so first we got to recognize, all right, are we making it smaller or larger? If I'm making it smaller, I know it's a fraction. I set up at any point. I could have taken any one of these. If I taken the 6 and the 3, 3 over 6 is 1 over 2. If I took E over here, okay, well this E is at 10, 10. And this E right here is at 5, 5. Well, if I set up as new over old, that's 5 over 10, which is 1/2. So you get to just pick one of them. It doesn't matter which one. And then that's going to be your scale factor. So try it on your own. Try this one. Find the scale factor and then write an algebraic expression of the dilation. So for this one, let me show you an example of how I wrote it out. How I would have written the algebraic expression for this one. I would add xy. My scale factor is 1/2, so that'd be 1/2 x, 1/2 y. So what I want you to do is we're going from the little one to the large one. So we know it's got to be a bigger number than 1. It's got to be multiplying it by something larger than 1. So try to figure out what the scale factor is, and then write it algebraically. So if you don't have an answer, I hope you pause it and you find the answer. Try it on your own. Okay. So I'll just use b. B's at -1, 1. Negatives don't matter. Our scale factor is always going to be positive. My new b, 1, 2, 3, 1, 2, 3. So I think a lot of people right away can see, okay, well, if I went from 1 to 3, that means I'm multiplying it by 3. But if we can't, I set up as the new one over the old one. 3 over 1 is equal to 3. So algebraically, my scale factor has got to be 3, so that'd be 3x, 3y. That's it. So one thing to remember, scale factor equals new image divided by pre-image. I'm gonna put a couple stars there. Cool. Independent practice. Try it. See how you do. That's all I got for you guys. Thanks for watching. Peace out.